Hey everybody, this is your host Bill. Have you ever imagined driving with a smart assistant that guides you through traffic, offers a personalized tour, and even helps find parking spots? This is the future of driving, where the digital avatar connects with external servers to offer interactive experiences. Making significant strides in this direction, a team of researchers from China and Singapore has recently developed a task migration system to ensure seamless and secure communication between the car and external servers. Their research promises to transform the driving experience and improve road safety and traffic management in cities. Today, we have with us one of the researchers, Junlong Chen. He is currently working toward the BS degree at the Guangdong University of Technology. We're chatting with him to understand more about this exciting technology. Hi Junlong, welcome. Your paper published in the IEEE-CAA Journal of Automatica Sinica introduces an augmented reality navigation system to assist drivers navigate 3D virtual spaces. It's a novel concept that the listeners are perhaps not familiar with. Could you describe this complex topic in simple terms for our diverse listeners?
Yes. Let me start with an introduction to the concept of Metaverse, which is basically like a virtual replication of the real world. It's an advanced digital universe where users can interact with both virtual and physical elements in a seamless and immersive way. To visualize this, imagine you are driving in a car that has an augmented reality display system. A digital avatar could appear in your augmented reality display, providing directions, pointing out landmarks, and suggesting points of interest. This avatar could offer a personalized touring, helping you navigating the streets more efficiently while enhancing your overall driving experience. In the context of vehicular navigation, drivers and passengers can engage with digital avatars that assist them in real time. These avatars could potentially help with many different things from finding parking spots to telling you how to avoid traffic congestions or even connecting with other vehicles. Having such technology will elevate the complexity of driving and improve safety and convenience for drivers.
Wow, that's so interesting. So, from what you described, this system must manage data and provide services in real time. A major challenge of implementing such navigational systems would be then their high computational demand, particularly in environments with numerous vehicles and dynamic traffic conditions. How did your team address this challenge?
Correct. To assist with the navigational tasks, the avatar needs a lot of computing resource to provide seamless experience, which is impractical for the computational resource limit vehicles to handle alone. So, it's necessary to offload the task to nearby servers on the roadside or the unmanned aerial vehicles flying overhead. However, the mobility of vehicles poses a significant challenge to the UAV assist vehicular metaverse to ensure the continuity of avatar service, especially when the vehicles leave the coverage of their host edge servers. To achieve uninterrupted and high-quality avatar service, each avatar should migrate online with its physical vehicles to ensure real-time and immersive avatar service experience. For the vehicular avatar task migration, the challenges are mainly focused on 3 points. First, the avatar tasks need to be not only migrated to the nearest edge server, but also migrated to the next edge server to reduce the total task execution latency. Thus, it's challenging to make appropriate migration decisions in the compressed environments. Further, when all the vehicles decided to migrate their avatar tasks to the same edge server, the edge server may be overloaded, which increases the avatar task latency. Finally, to ensure the resource trading security and the transferability during task execution, It is critical to protect the security of resource recording between the edge servers and the vehicles. So, to address the above challenges, our study proposed a dynamic avatar task migration framework. By using advanced transformer-based multiple agent reinforcement learning algorithms, we can quickly and reliably determine the best migration decisions. Thus, we can effectively reduce the latency of avatar service to maintain immersive experience. Besides, the incentivize the each servers to contribute adequate resource to the vehicles. We maintain the transaction records of communication, computation, and the storage resource exchange between the edge servers and vehicles in the blockchain, utilizing the smart contracts to ensure the security and traceability of these transactions.
That was very clearly explained. Thank you. Can you elaborate on these advanced algorithms for our listeners? Perhaps you can tell us how they were implemented and how they helped efficiency.
Yes. First, let me talk about what task migration is. Put it simply, task migration refers to the transfer of particularly executed tasks to another node in a distributed system. By utilizing deep reinforcement learning, digital avatars or agents can be trained to make optimal task migration decisions in various environmental conditions using real-time data. In this process, an agent observes the state of environments and is rewarded based on the effectiveness of its actions, such as deciding when to migrate a task. However, these algorithms by themselves are not feasible, particularly in the dynamic environment such as the city streets with moving vehicles and the unpredictable obstacles. To address this, we integrated the transformer into a multiple agent proximal policy optimization algorithm. It is a multiple agent deep reinforcement learning algorithm where agents train together but can independently decide the best time for task migration. The transformer has an attention mechanism that captures the sequential information because between the vehicles and their surrounding environments, making them well suited for the decision making in avatar task migration in dynamical environments. For instance, the action or decision to migrate part of the workload to an external service is made by the digital avatar based on the observation or data gathered from the surrounding environments, such as its location, traffic condition, and available edge servers, instead of treating each observation and action as an isolated event. They are considered part of a continuous sequence. This means that the choice to migrate a task to an external server depends not only on the current observation, but also on the past observations and the anticipated future conditions. This approach allows the digital avatar in each vehicle to then decide in real time the most optimal time to migrate or migrate its task to the server, even in dynamic environments, reducing the overall latency or delay in communication.
Hmm. Okay, so if I've understood this correctly, payment transactions and sharing individual details would be a part of availing the avatar services, right? For example, if you wanted a city tour. A major concern users might have is how the security of these transactions between the server and the vehicle is ensured. Could you address this?
Yes, when the users wants to use avatar service, their vehicle sends the necessary resource requirements to the edge servers. The edge servers then determine the prices that the users must pay for this resource. These transactions between the vehicles and the external servers are recorded using smart contracts deployed in the blockchains, where they record in a ledger, ensuring that the details such as the user's address, resource demands, resource price, payments made remain secure and cannot be alerted. Once the users pay for the request resource, the edge servers calculate the appropriate resource to the avatar service.
Okay, great. It looks like users need not be concerned about data security. Another thing that I think people would be interested to know, how does the proposed method compare to current avatar task migration methods?
Mm. To evaluate our proposed method, we conducted simulations where vehicles interact with 3 edge servers along a main city road. All the vehicles were assumed to travel at the same speed for simplicity. We found that our method outperforms the advanced multi-agent reinforcement learning approaches by approximately 2% and reduced the avatar task execution latency by around 20%. In addition, we recorded the transaction data of computation, and the storage resource between roadside unities and vehicles in the blockchain to ensure the security and traceability of transactions.
Thank you for that insight. I'm sure imagining a world where this is all a reality is quite exciting for our listeners. Tell us, what are the next steps in your research? Are there any upcoming projects or extensions of this work that you're excited about?
We are now looking to further optimize the model and make it scalable for the real-world applications. One area for improving is integrating the pre-trained models with a transformer model to improve the sample efficiency. The other can be utilizing the model compression technology to reduce the size of machine learning models without significantly affecting the performance. These improvements will make our system more practical and useful in the various situations.
Definitely. So, one final question for you. How do you see the field of vehicular metaverses evolving in the next 5 to 10 years? And what role do you hope your research will play in that evolution?
In the long term, this research could lead to the widespread adoption of highly interactive and immersive vehicular service, transforming the driving experience. People could enjoy the advanced AR navigation, real-time virtual tours, and personalized entertainment while traveling. The technology could also improve the road safety through better navigation aids and real-time updates. Furthermore, the efficient use of computing resources and security transactions could pave the way for more sustainable and scalable smart city infrastructures.
Wow, that's exciting. Thanks a lot, Junlong, for joining us today. I'm confident that the innovative technology developed by your team will radically transform the way we drive soon. I hope that our listeners enjoyed this insightful discussion. Thanks, everyone. Goodbye.